This is the extra for experts bit. Where do the t and the z values come from? They're both based on a normal distribution. A z distribution is a normal with a mean of blah, blah, blah. Okay, the confidence intervals for proportions use a normal approximation of a binomial. Don't need to know that. Basically, read that if you're interested. The thing you want to know is that this bit here, if you find that bit back in the previous spreadsheet tricky, you just use this. So if you're doing a 90% confidence level, you use a z value of 1.645. If you're doing 95%, you do 1.960. And if you're doing 99%, you do 2.576. And we give those to you in the quiz. So it's much easier than doing the bit I just showed you. So never mind. It's always good to show you the really good way to do it as well as easy. And in case you wanted to know where the t value came from, if you wanted to just check that data analysis was doing it right, you use a thing called tinv and blah, blah, blah. Okay? That will do. Right. This is more important. Factors influencing the confidence interval. And you have questions on this. You really want a confidence interval to be as narrow as possible because otherwise it's not giving you any information. But at the same time, in order to make it narrow, generally you have to be less confident. It's sort of like, say we're going to try and catch something, like a little bug or whatever, and we've got a little net about this big. It's going to be much harder to get it, but it's a very nice little net. But if we use a great big net, we're much more likely to get it, and that's what a large confidence interval does. So if we wish to be more certain, we increase the confidence, say from 95% to 99%. I want to be more confident. As a result, the confidence interval becomes larger because, see here, 95% we're multiplying by 1.9, just under 2, but 99% we're multiplying by 2.5. So we're getting another half of a standard error each way more in order to go from 95% confident to 99% confident. Okay, if we want a narrower confidence interval, then we'll be less confident that we've caught the true value. So say we wanted to say, okay, I want to make it smaller, we could go from that down to the 1.645, but then we'd only be 90% confident. So then, actually if we come back to this one, which has got an n on the bottom, and this one, which has also got an n on the bottom, well, a square root of an n, and actually that's a square root of an n too, because there's a square root on the outside. Okay? So, if we make n bigger, if this n gets bigger, we're dividing by a bigger number, therefore this thing gets smaller. And intuitively it makes sense. If we take a bigger sample, we're going to get more information so we can be more accurate. So say if I'd taken a sample of 10 rather than 5, all of those confidence intervals would have been smaller, and because there is a very good reason for them to be smaller, because we've got more information. The more information we get, the more we can shut things down. But it's not linear. It's not like getting... to go from 10 to 20 is a really big improvement. To go from 100 to 110 is very little improvement at all. And this is why an awful lot of sampling stops at 1,000. At about 1,000, it's going to take you a lot more money to get much improvement. So 1,000 tends to be a popular number, and if you can possibly afford it. Okay, so if we have a larger sample, we can get more information, blah, blah, blah. It's only a square root effect, I think I said that. And the other thing too is it depends on how variable the population is. That's only in these ones here. If we had asked a question like, oh God, how old are you? There's not much variability in this class, so we would have had a smaller confidence interval. But we asked how many hours you'd spent in the last week, and there's quite a bit of variation, so we get wider confidence intervals. So what I'm saying here is, if you've got a very variable population, you'll get a very variable sample, which will give a wider confidence interval. If you have a homogeneous population, one that's very, very similar, you don't have much variation, and your confidence interval will be much smaller.